So now that we're kind of motion tracking adepts in a sense, I suppose we can start moving on to the environmental understanding side of things. There's a little bit more going on with the environmental understanding. Like just even in terms of the code, it's like with motion tracking, there's one thing, and you're trying to figure out where it is and which direction it is for the device. And with environmental understunderstanding, there's really two things that we can like at least focus on for now. Is like the feature points, which that's just like it's just a big old list of vector 3s, right? All these points around the space, and that's like those little dots that you'd see in the Hello AR example, and they change every frame. So that's a little bit for doing any creative sort of like I don't know, app ideas, that sort of thing. It's a little bit too fluid to actually, well, at least with that raw data, actually, like I don't know, like create an object on it or a mesh out of it, sort of thing. You maybe require a bit more processing, but what the other thing that ARCore gives us is the planes, and they're much more stable, and they're like it retains them over several frames, and even after you look away from a plane or walk into a different room, you come back and ARCore will actually pick it back up again. It'll merge different frames together. It called it a subsuming. So one plane will actually like engulf another, and they'll two planes will become one plane. And so we have all this like really nice functionality, which we can jump right into. I suppose it'll be a little bit like the motion tracking episode where you look at how they sort of did it in Hello AR and take the meat of it. What we want to do is look at that code and take the stuff that's the core functionality of it, and that's the stuff that we can really use. So we can sort of just jump right in and start coding it, I suppose. First thing, I'll just set up the environment again. Always worth like, I don't know, getting a bit of a flow for exactly what's needed. Switch to Android, and every time I do it, I learn something new as well. Like I noticed that it keeps like freezing whenever the orientation changes, and you can adjust that right here where it says default orientation. Just change that to landscape right or landscape left or something, and that'll keep it locked into one of the orientations. Just stop it from freezing. Yeah, and then we can just go to do our other four settings. Multi-threaded rendering. We'll call this one environment. And 7.0. And what was the other one? Oh yeah, XR settings. Okay, so we're just going to change that to ARCore supported. All right. And once again, we just import all of our package. Drag and drop that into assets. Again, we don't need this Hello AR example. We're going to sort of build our own. And yeah, from that other tutorial as well, we're just going to do add those two components to the main camera, which will give us the motion tracking that we need. And then we're going to create one prefab, which will be, I'm going to call them surfaces, just to differentiate so that we're not exactly creating the same class. I'm just going to call like a plane is just going to be a surface, and we're going to have a surface generator. So we're going to have we're going to add a surface generator object, and then that's going to know what the surface prefab is. So it'll create a new one every time that ARCore tells it that it found one. So before we do that, we'll just quickly add in these the session component and the pose driver. Tracked pose driver. The pose driver, all we've got to do is make sure that's color, camera, and I believe that's all we really is the most vital thing to do. We can drag our camera into first person camera. And AR session config again is just right here. Okay, And now we're going to create a new game object. Just call this surface generator. Okay, and all that's going to have is a new script on it, and we'll call that surface generator as well. Okay, yeah, so this is the equivalent of the AR in Hello AR. It's like the AR controller, but that has a whole lot of extra functionality that kind of, I suppose, it skews a bit like the, you know, what it's really at its core doing in terms of the environmental understanding, which we can sort of focus on to understand it. Yeah, so what we really got to do is we just got to check every frame, and we got to ask ARCore whether or not it's found any new planes. And if it has found any new planes, we got to create a new actual mesh, right? So, and we're going to use a prefab. So every time it finds a plane, create a prefab. Okay, so first of all, we'll just declare that prefab. We'll call it a game object, public game object, and we'll call it the surface prefab. Okay, and now just in our update function. First of all, oh yeah, and we need to whenever we use ARCore, we just need to import the library. So using Google ARCore. And then we just say if frames the object that we get all that information from, and if it's tracking state, if it's not currently tracking, that's either if it hasn't started tracking yet, or it's lost tracking, doesn't have enough information, then we don't want to ask it anything. So we'll just get out, you know. So it's kind of a return statement. So if the tracking state is equal to frame tracking state dot so sorry, if it's not equal to tracking, if it's anything but tracking, then we're just going to return. Okay, see how that goes. Frame.tracking state. Oh, I'm sorry, this is just a little syntactical error there. Okay, if not equal to. All right, and now that we know that we're tracking, all we got to do is we got to get a list of all the frames. I've got myself a little helper sheet here because there's a few things to remember for this one. Okay, so. Yeah, so the next function we need is the get new frames function. So go to frame dot get new planes, right, is what we're doing. And so how we do this it seems like a lot of these ARCore functions is, instead of the function returning something, we pass something in by reference, and it's going to fill it up for us. So for example, it's saying, okay, well, if you give me in a variable which is a list of track planes, I'm going to fill that up with all the new ones, and then you can do something with it. Okay, so we'll just create a new list of track planes. Okay. We'll call it new planes equals new list of track planes. Okay, and then we just pass by ref new planes. Now, my understanding is that it is being passed by a list is being passed by reference anyway. I believe it's just being explicit, you know, saying we really are going to do something with this and pass it back when we use this ref keyword. Yeah. Okay. So now we can say for each var p in new planes. So for every new plane, what we want to do is we want to create a new surface prefab. So we just go game object dot instantiate surface prefab, and we're going to set that position to 0 and its orientation to 0 because that's stuff that's going to be taken care of later inside that prefab. So we go vector 3, 0 and quaternion dot identity. Last thing we need to do is just in that prefab, we actually haven't created the class yet, but we're going to have a surface class, which is going to it's going to be self-managing plane essentially. So whenever something moves, whenever ARCore updates the position, or two planes like merge together, or something happens, that's all going to take care of itself. So it needs to know which plane it's going to be referencing. So it can ask ARCore, oh, okay, I need to check up on this plane. So we'll just say, for example, so we just got to set this to a variable. So var go equals, and then go dot get component. It's going to be called surface. It's not there yet, so it's not going to like that, but you can deal with it. And then we just go, we're going to just say tracked plane, lowercase. Okay, and we're just going to equals p. Okay, and yeah, that's actually everything for this class. It's not a very complicated one. Okay, and now we can jump back into Unity, and we're going to create a new game object. This is going to be our prefab. We'll call it surface. Okay, that's going to have a mesh filter because we're going to create a mesh procedurally. So yeah, mesh filter with no mesh in it, and a mesh renderer as well. Now, what we really want out of this, what would be very useful at this point would be to actually visualize where those vertices are, the bounding vertices, because currently with the ARCore planes, you might notice that they sort of fade in the corners, and the patterns, the triangular grid, that's not actually correlating with where the bounds of the plane is, which it looks really good, and it's really useful for for attaching things, getting a sense for what sort of how do you say, like in 3 dimensions, what Google AR is able to see, but it would also be really handy for us as developers to see exactly where those polygons are and how they're moving around and how many more are being added every frame. So to do that, luckily, Unity these days seems to come with this really handy spatial mapping wireframe material. So that's going to highlight all the edges, and it's going from vertex to vertex, and it's also going to tell us. I believe it changes color every meter or something. So yeah, it'll tell us a little bit about how big something is, how big a plane is. Okay, so now that we've done that, last thing we need to do is just create a surface script. Okay, and then we're just going to attach that to the okay. Oh yeah, okay. So first of all, we're just going to need to fix up this surface before we can attach it as a game object. Okay, so we just call that. We're just going to add in the using ARCore. Okay, and we're just going to have a public track plane. Tracked plane. Okay. And so I suppose we can fill in the rest of this script before we jump back. Okay. So there's a few little things to do in this script. But first of all, I suppose the first step will just be go through all the I think of them as all the return cases, all the cases where we don't want to know about any updating or anything like that. Okay, so for example, this track plane if that's not, if it's not existent, then just return, right? So that we're not going to get any errors at runtime. So if tracked plane is equal to null, then we're going to return. Okay, then if the next one is if the, what is it? Oh yeah, okay, so now we've got to remember if this plane that we've created, remember we've created this prefab for this one plane, and there's another plane here, sometimes they merge together. And yeah, so that's called, that's a variable called is subsumed by. So for example, if we say tracked plane dot is subsumed by, all right? Oh, sorry, just subsumed. If tracked plane dot subsumed by is not equal to null, so if it has been subsumed by another plane, then what we want to do is we actually want to delete this entire game object because it's not relevant anymore. Okay, so we can just say game object, oh sorry, destroy game object, and then return. Yeah, I suppose we can make this an else if, be explicit. Okay, now the next one is if it's not a valid plane, and also if the frame's no longer tracking. Okay, so we do this really easily. So if tracked plane dot is valid, let's see that one, or frame tracking state is not equal to frame dot tracking state is not equal to frame tracking state dot tracking. In that case, we're going to want to just disable the renderer. So you know that's in the case where, oh, maybe we've looked up for a while, it's all blue, oh, we're not tracking at the moment, but we don't want to delete it because maybe the user will look down and then it'll find it again. So it's still like, you still want to hold on to the information. So what we can do is we can say get component mesh renderer dot enabled equals false, and then we're going to return. Okay, because we don't want to do any updating. Yeah. Actually, you know, it might be cleaner to actually we should probably reference the mesh and the mesh renderer up at the top here. So we just say mesh renderer, and we'll just have a mesh. Okay, and then we can do this once. I've noticed there's a few little things throughout ARCore where they do this. They do this like a little optimization things, or like with the point cloud, you know, like assign, like reserve all the memory at the beginning so that, you know, for all the vertices, so that for every update you're not finding new memory for every single update. You know, just the little things that you notice them doing, like going through someone else's code. Okay, so now I can just say mesh renderer. So mesh renderer is equal to this, and then the mesh. We're gonna leave the mesh. Actually, leave the mesh for now because we're gonna create a mesh. Yeah, no, I'll leave that. Actually, no, we do want to do that. We want to create a mesh yeah, totally. Okay, so when the game object's created, we create a new mesh, and then we just update the vertices of that mesh. We don't delete it every time that we get new vertices. We're just gonna, update the vertices and also the triangles. So we just say mesh equals new mesh, and get component mesh filter dot mesh equals mesh. Okay. So now whenever we update the mesh, our mesh filter will update also. Okay, so now, let's see, what are we up to? Okay, so we say mesh renderer.enabled equals false. Okay. Okay, so now we've got rid of like all these occasions in which we don't care what, like we don't want to read into what's happening with our tracked plane. Now we're going to go into the cases where we do. So if none of these cases have been met, then we want to absolutely make sure our mesh renderer is enabled. Dot enabled equals true, and finally we want to ask if the tracked plane has any new information for us. So we say if tracked plane dot is updated, then we want to update vertices. So we'll create a new function called void update vertices. Okay, and then we'll just go update vertices. Cool. Okay. Now, okay, so now finally we're onto the geometry part of the thing. There's a simple way and a complex way to do it. The first way that I did, out of interest, the first way that I did it just quickly was like you take all the vertices, right, and then you just create like you join it, just like there's a really simple, it's called a line strip, where it just joins all the dots, and that's just a really good way of just like visualizing, okay, yeah, you know, you're on the right page with all the with all the code, kind of like just I like to incrementally check how it's all going, but we might as well just do it properly and go straight to the straight to the juicy part. Insert break here to explain the math behind it. And then we're just going to go into the algorithm. So yeah, we're going for that like pincer shape, okay. And we're going to first of all we're going to create a new list of vertices. So 3. Okay. Now the function we want to get the updated version of all the vertices is called the get boundary polygon. So we go tracked plane dot get boundary polygon. Yeah, and we're going to pass in all the vertices. Okay. Okay, so that's going to give us all the boundary ones, right? And then we're also going to append to the end of that the center of the center of our polygon, so that we can create triangles. Okay, so say vertices dot add tracked plane dot position. Okay. Now we're also going to create a list of integers, which will be our triangle indices. Okay. So this is the math part. So okay, so we want to go for all of the vertices minus this last one that we added in the middle, right? So it'll be, yeah, for every boundary vertex there will be a triangle. So I is less than vertices dot count -1. Okay. Okay, and now what we want to do is we want to, okay, yeah. So for every triangle, the first one is going to be the index of the last, the index of this center position, this center vertex. So we say triangles dot add we say vertices dot count minus 1. Okay, and then next, absolutely every time, triangles, we're going to add just the I. So just the as I increments for, you know, from 0 to say 3, 0, 1, 2, 3, you know. So yeah, so we just add triangles dot add I dot add I. And finally, we just want to make sure that when we're on 3, that is because it's going to go 0, or it's going to go from the center 1 to 0, 1, then, you know, center 1, 2, center 2, 3, center 3, 0. So when it's on 3, which would be vertices.count minus 2, that's when we want to make sure that we're going to add a 0. So how we can do that is just a little ternary operator, triangles.add. We say if I is equal to vertices.count minus 2, and then if it is equal to that, we want it to be 0. Otherwise, I plus 1. Okay, I hope that's kind of making sense. Okay, so now we can say mesh dot set vertices. Okay, we're going to have to convert the triangles to an array. So set triangles, just because that's how it wants it. Set triangles dot to array, and submesh 0. Okay, and then we want to recalculate our normals and our bounds in case we do decide to use a shader that uses light. Okay, so mesh dot recalculate bounds and also mesh dot recalculate normals. Okay. Okay, this should be everything. So yeah, let's see if we can build it up and see how it goes. All right, just a few more things before we build. First of all, we want to grab this surface script, put it onto our surface object. Okay, now our surface object is complete. We can bring it down into our assets folder, and that's actually going to create the prefab for us, which means that we're able to delete that instance of the prefab, and now we can go into the surface generator and drag our surface prefab into this object space. Now, this final tidbit is I want to write a massive sign and wave it around, sing a song about it. I've made this mistake a few times. If I go into this main camera, have a look at this transform. See how the position's at 1 and -10, right? So I'll build the app and then I'll be like, oh, it's not working. I don't get it. Like, what's going wrong? And then I'll look around and see, wait, it is working, but it's working all the way over there. The camera starting 10 meters away in AR world, 10 meters is actually 10. Like, it's decent. It's far enough away to think to make one think that something else is going wrong. So super, like, we really want to drill it in my own brain to reset the transform of the camera, because by default that's going to be at 1 on the y-axis and yeah, -10 on the z. So yeah, so just making sure that transforms at origin, and then we build. Okay, so here we are. We've got our forming meshes. We can see a little bit of spatial information, but what's really valuable is that beautiful shader that's actually telling us exactly where the polygons are and how they're sort of moving and morphing over time. Let's see. So you see how they you see them jump a bit. I'll see if I can create a new one over here, and we can watch them sort of converge on each other. Okay, so there's that new one. You see how they sort of move, and we're really getting a lot of information about how they sort of, oh, there we go, come together. And we can see exactly where that sensor is. And you can imagine all kinds of things we're able to do now with this information. Yeah, cool. So okay, anyone has any sort of any ideas or anything they'd love to throw in would be awesome. Probably next tutorial come up with some sort of creative application of this. I'm not sure what it'll be yet, but yeah, I'll let you know. All right.